Let's just jump right in. You hit send, and boom, magic happens. At least that's how it feels, right? But if you've ever found yourself wondering how your seemingly invisible digital life actually functions in the physical world, well, you're in exactly the right place. Welcome to This Explainer. Today, we're going to strip away that illusion of the cloud and take a real step-by-step physical walking tour of the internet's hidden infrastructure. We're talking about the actual steel, the fiber, and the protocols that make our hyper-connected world possible. We are stepping inside the architecture of connectivity. To kick off this journey, I want you to imagine sending a high-resolution photo from your phone to your neighbor sitting right next door. Seems perfectly simple, but here's a kind of wild question. How does that data actually cross your city without first traveling completely across the globe? See, in the early days of the internet, we had this massive headache called the transit problem. Local traffic would unnecessarily cross international borders, sometimes bouncing to entirely different continents, just to route right back to a computer 2 blocks away. It caused astronomical costs, terrible lag, and massive inefficiencies. It's literally like taking a flight from New York to London just to get to Boston. Makes no sense, right? Okay, let's dive into this, because the solution to that crazy transit problem is the absolute heart of what we're looking at today. The fix is the Internet Exchange Point, or IXP. An IXP is a massive physical hub. I'm talking a very real concrete building filled with real cables, where different internet service providers, or ISPs, and content delivery networks physically connect their equipment to exchange traffic directly. We call this process peering. And by peering at an IXP, networks completely bypass those long, expensive international transit routes. Physical distance drops, which completely slashes latency so your video calls don't lag. Costs totally plummet, since networks aren't paying third parties to haul their data around the world. And bandwidth explodes because they're linking up directly with high-speed physical cables. To really wrap our heads around the mechanics here, it helps to think of an IXP as a massive central hub. Honestly, very much like a grand central station for data. It's where various tracks meet, so passengers can switch trains without having to travel out to some distant terminal. We're going to use this metaphor as our map moving forward. The massive tech companies and the ISPs, those are the train companies. The fiber optic cables, those are your physical tracks. And your data packets, like that high-res photo you just shot over to your neighbor, those are the passengers, desperately trying to switch trains as fast as humanly possible. So let's actually take a walk inside one of these hubs. First up, you approach a high-security data center. We're talking biometric scanners and man-trap doors. I know, it sounds like a booby trap from an Indiana Jones movie, but it's really just a highly secured double-door checkpoint. Once you clear security, you step into the colocation space. Picture this. A vast, heavily air-conditioned room filled with rows upon rows of towering metal racks. This is where fiercely competing tech companies physically bolt their own routers right next to each other in the exact same room. Next, you reach the beating heart of the whole facility, the high-performance network switches. These massive, highly specialized computers act as the central crossroads. And finally, you have the fiber optic cross-connects. These are the literal glass cables running from a network's router to physically plug right into the IXP's central switch. This is the exact physical spot where your neighbor's photo will cross paths with your internet provider. But here's the catch, right? You can plug in all the physical glass cables you want into a switch, but the networks still need to speak the exact same language to know how to talk to each other. Enter the Border Gateway Protocol, or BGP. If the IXP is our grand central station, BGP is the station master standing there with a massive megaphone. It's the routing protocol that allows these interconnected networks to announce to everyone else exactly which IP addresses they're responsible for. It's basically an ISP shouting over the network, "Hey everyone, I have the tracks that lead to all the homes in this specific zip code." Let's move to and see how this builds. Let's follow that photo you sent to your neighbor through a rapid 3-step BGP handshake. First, your neighbor's home ISP uses BGP to announce, "I am responsible for your neighbor's IP address." Got it? Second, your mobile network hears that BGP announcement and mathematically agrees to exchange traffic via the absolute shortest path across the IXP. And third, the IXP's high-performance switch executes the handoff. Your data packet, the photo, flies down your mobile provider's fiber optic cable, hits the central switch, and is seamlessly shot down the home ISP's cable. This incredibly complex physical and software negotiation, it happens in literal milliseconds. It's mind-blowing. Now, as you can probably imagine, not all traffic is created equal. Public peering is like the main concourse where your neighbor's photo just traveled. A network plugs one cable into the shared IXP switch, and boom, suddenly they can exchange traffic with hundreds of other members all at once. It's incredibly efficient.
But what if your neighbor isn't receiving a single photo, but is instead streaming a massive 4K movie from a giant platform? Well, that much traffic would completely overwhelm the public switch. So they use private peering. They bypass that main concourse entirely and run a dedicated, private physical cable directly between their two massive routers, right there within the colocation space. It's basically a VIP tunnel built exclusively for massive, heavy data loads.
So who exactly is hanging out in this building? It's a surprisingly diverse ecosystem. You've got the access ISPs, the folks providing internet to your living room. Then you have the massive content providers like Google and Meta delivering mountains of video. You also have CDNs, or content delivery networks, whose entire job is to sit in these physical IXPs and cache website data, so it's physically much closer to your laptop. And finally, you have government and academic networks, using these hubs to securely transfer massive scientific data sets. This single physical location unites all of these entirely different players under one roof. It's pretty amazing. Zooming out from the servers and the cables for a second, the existence of these physical hubs really shapes our global economy. Let's say a ship drags its anchor across the ocean floor, or hey, maybe even a shark takes a bite, and accidentally severs a major international subsea internet cable. In the past, entire countries would just go offline. Dark. But today, because of IXPs, your local banking, government services, and domestic communications survive the cut and stay perfectly online. Plus, regions that invest in building robust IXPs naturally attract massive investments from tech companies looking for cheap, fast connectivity, which in turn fosters a booming local digital economy. But look, the internet never stops growing, and Grand Central is getting pretty crowded. These hubs are facing some unprecedented challenges right now. Security is absolutely paramount. Because BGP relies on trust, networks honestly announcing who they are, IXPs are having to implement super strict security protocols to prevent root hijacking and massive distributed denial of service, or DDoS attacks. They're also transforming into the edge. Instead of just routing traffic, companies are putting massive processing power right inside the IXP itself, so that things like autonomous vehicles and smart cities can get near instantaneous computing power without waiting for a signal to bounce to some distant cloud server. And this brilliantly illustrates the sheer scale of our digital future. Just look at one massive number, 800 gigabits per second. To keep up with the tidal wave of data driven by 5G networks, the Internet of Things, and the absolute explosion of artificial intelligence computing, modern IXPs are radically scaling their hardware. A single port on a modern IXP switch is literally being engineered to handle 800 gigabits of data every single second. Just try to wrap your head around that unbelievable volume of information pushing through a piece of glass thinner than a human hair. It's almost hard to fathom. Well, we've reached the end of our physical walking tour of the internet's Grand Central. We've bypassed the man-trap doors, followed the lightning-fast BGP routing handshakes of a single photo, and mapped out the incredible ecosystem of networks that rely on these hubs to function. Which leaves us with one final, provocative question. What would happen to your seamless, instantaneous web if these invisible physical hubs simply ceased to function tomorrow? Our digital world feels like magic, but as we've seen, it is deeply dependent on very real, very physical foundations. Internet exchange points are truly the unsung heroes of our digital age. Thank you so much for exploring this with me, and keep questioning how the invisible world around you actually works.